Okay, I want to show another oddity on magnets and maybe Hall sensors or, pole identifiers and my little Gauss meter, but they both use the same Hall sensor. I've got a couple of N56 neodymium. They're 1-inch cylinders by 1-inch diameter, 1 by 1 inch, 1 inch by 1 inch. I've marked the blue side with blue tape. And unlike academia or the government, I don't have any red tape around here to put on the red side. Haha, LOL. I have two of them. And, you try and put them together, same poles, they push hard. And I've had them together opposite poles, and I've got many blood blisters from that, because once they get close, they go. And I have to use a vise and some padding and a pair of gloves to get them apart. These N56s are powerful. But what the oddity I'm looking at is just like this regular little N42 1/4 inch by 2 inch magnet. You get a south, then there's a dead spot in the middle, and then north, then dead spot, and then south. There's always a little dead spot on long magnets. And every magnet has a spot where it switches from north to south, but the longer the magnet, the bigger the dead spot. If you see north, dead spot, south, which I've known that or have shown that too since I, kind of discovered it. But what I found is odd is when I put one of these, this is a 1-inch, just a steel rod, and this is just a 1-inch steel ball bearing. They're not magnetized. They're magnetic, but not magnetized. If you see that, they don't stick. But what's weird, if I put the south end of one magnet to this 3/4 inch bar, and then I put the north to the other, like so, it basically does the same thing that little magnet did. It goes from a north to a south, goes along, and I've got a south to south. Let me get the north over there. So now I've got south to north, if you see that on this bar. I'm using this real long bar because I want to show you what it does. So the end of the magnet here is north, then it goes south, then it goes along, then there's a dead spot, and then it goes north again to this north magnet. So that does the same exact thing that the little magnet did that was all one magnet. I've just taken this one north to one end, south to the other end, and extended it. So that's like a longer magnet, but you see it's got a dead spot there to there, but it's north to south. That's not the odd part. What's odd is now I'm going to put them south to south, and with this long bar, you can do that. And I'll show you. Got a north out there to a south in here, and a north out there to a south in here. But what's strange is this is going to show south all along the bar. Okay? And that's, you think, okay, you got two souths together. That should make sense that it's all south. What I don't understand is your north and south, according to what everybody says, the rotation is what causes the Hall sensor to determine which is north, like that, it's rotating that way, and the south on this side is rotating the same way, but it's from the other end. And that's why the pole finder goes from a green to a red, because of the way it's detecting that rotation. And I don't understand, since this one is rotating this way, if you see, this one is rotating this way, the whole magnet on the bar, but the other end is rotating the other way. If you see, it's rotating that way. Okay, so they're opposite rotations, I'm guessing somewhere in the middle. The blues are meeting each other. And what's got me is why does it still show a south all along with the meter or the volt or the pole finder in the same orientation all along, if the rotation, like I said, this one's rotating that way up to a certain point, this one should be rotating the other way up to a certain point. So even if they're both pulling in, as I say, to each other from the middle of the bar, they still should have opposite rotations, but the pole finder still knows that there are two souths. All along there, it knows it's south poles, not the north, see? There's the north, but it knows it's the south, and then out here's the other north. And another thing I should have showed a while ago, with it like this, there's no dead spot in the middle. If you see, it will hold the ball bearing in the middle. See that? It's got magnetic power. Now watch, I'll put the ball bearing down. I'm going to flip one of the magnets. Now I'm north to south, okay? South over here, north over here. Now it doesn't stick, okay? And this means, you know, according to our rotation, the inside of the bar, or the entire magnet, both magnets in the bar are all rotating in the same direction now, just like that. See what I mean? They're all rotating in the same direction, but I have no pull in the middle, not till I get down here towards the end. And I have to get way to the end for it'll even lift the bar, see? Look at that, how far down I have to get, and there's nothing in the middle. But when I flip one of these magnets and make them south to south, I have a traction in the middle that will even pick up the whole bar, if you see. It picks up the whole bar. It's hard to keep it balanced, but it'll pick up that entire bar. All kinds of magnetic power in the middle when it's south to south. So it kind of perplexes me. I can show you with the Gauss meter the numbers. It shows the same thing. North to south, it goes to 0 in the middle. And as it is now, if you can see the numbers, it shows a drop, like it's 140 some on at the pole, and then it'll drop down to 65, 59, 54, somewhere in the middle, and then goes back up to 140 some on the other pole. So it's got power all along, even though, according to the TV screen in the direction of rotation, it's rotating this way on this end, because that's the way that magnet's rotating, to the left, but this magnet should be rotating to the right. And I don't understand why this pole finder shows that same it shows a reading of a south all along it. So, you know, it's kind of an oddity to me. Oddity how the magnets work that way, because I can't put two souths together by hand without this bar. If I don't put at least 3 or 4 inches of steel between them, they will not go together. But I don't have hardly any trouble putting them together like this, you know, south to south or north to north. And by the way, north to north does the same thing I'm showing you with south to south. There's no difference. It's just north instead of south all along the whole bar. The only time it changes is when you put them, both magnets, you know, end to end, south, north, then the bar gets that dead spot in the middle. Okay, so what you saw before was what the pole finder shows is going on. So now I've got the bar, and I've got it, you know, north to south that way, north to south, and this one is north to south that way. So in between here, we're going to have the dead spot in the middle, if you remember what I just showed you. So if you look, you know, if we look at it, the south side rotates it to the left, the north side rotates it to the right. We know that. Let it come back on. Here's the bar. So if I put it back here, and remember, we're north to south now, there's the dead spot in the middle. It brings it up, but it's a dead spot in the middle. It don't twist it, okay? Because I can flip the bar over and it'll take it down in the middle, but it really doesn't twist it. You see, it just moves it down, kind of like the side does without the bar. I can show you that. Just a magnet. There's the north to the right. Oops. South to the left. This way pushes it up. The other way pushes it down. I've showed that 1,000 times. Now, we're going to go south to south. South to south, where there should be no dead spot in the middle. Now watch what the TV screen does. It's up on this end, then it twists like that. Then it goes down on that end of the south. You see that? They're opposing each other, but apparently they work together. Up and down, up and down. And in the middle, it just twists it. And if I flip it over, it twists it the same direction. It's south all along. No matter which way I flip it, it twists it the same direction. See? But that's weird. South towards each other. It goes up on this end and down on this end. Up and down. Now if I flip it, it's still up and down. Up and down. And you notice the little vortexes in there. Look at them all along, and then they twist when you get to the north end. All along, and they twist when you get to the north end. But that's what it does. Up on one end, down on the other. And these two are rotating in opposite directions, and that's showing that because there's two souths together, but I don't know where they meet each other. They don't really seem to swap till you get to here. Then it kind of rolls over to the north, stays that way all along, and then bows down. See how that bows? And this side curls up, this side curls down. So that's what it's doing. With the south to south, and this whole thing, let me show that again. Let me get it set where I can show you. The whole bar is going to show a south all the way along. One end, I guess you can see it, one end to the other is south. And this is what it does. Up on one end, down on the other. Up, down, up, down, up, down, and it'll do the same when I flip it. Right side's up, the left side's down. Ponder that. Give me your thoughts. Laters.